Now I will tell you all how all this rocketry works. The thrust in a water rocket works by Newton's third law, as the ejected water and air provide a force that push the rocket in an opposite direction, providing an upward thrust. This is a bit like a balloon being released. The rocket also has gravity acting on it. In the diagram, these are represented by the up and down vectors respectively. The rocket will not maintain a constant thrust and will eventually start coasting. At this point, the rocket will accelerate back down to Earth due to gravity. Factoring in the force of air resistance, the final free body diagram of the rockets is this. The rocket also has a center of gravity upon which it will rotate. The rocket also has a center of pressure, where most air pressure seems to act on. This affects the stability of a rocket. The higher the center of gravity, and the lower the center of pressure, the more stable the rocket is. That is why the rocket has fins. These are to trap air and lower the center of pressure. And the nose is heavier to increase the center of gravity. After completing the experiment, we found that there is one rocket that flew the furthest. It flew 117 meters with a launch angle of 50 degrees and an air-to-water ratio of 60 to 40, or 40% water. It also had a fin angle of 30 degrees and a round nose. Although this may be the best rocket, we recognize that the wind may have affected our results. Thus, we have decided to look at the averages of each category instead and find the average for the best rocket design. The best type of nose is the cone nose. The best launch angle is at 50 degrees. The best water to air ratio is 40 to 60 with 40% water. And the best fin angle is 0 degrees. Combining these, we get the best rocket design. In conclusion, after months of testing and launching, we have derived that the factors that affect the performance of a water rocket is the launch angle, water to air ratio, nose shape of the water rocket, and angle of fins. We have also identified the best setup to launch the rocket the furthest. We have also found out that there are many other variables that we could have tested, such as the effect of weather and the type of the bottle. The findings of our research could be applied as an education tool as well as for practical uses such as propelling devices and objects.